Hello and welcome to today's ACM Learning webinar. This webcast is part of ACM's commitment to lifelong learning and serving the over 97,000 computing professionals and students who are ACM's members. I'm Will Trace, Lockheed Martin Fellow Emeritus, former chair of ACM SIGSOFT, and member of the ACM Professional Development Committee. For those of you who may be unfamiliar with ACM or what it has to offer, here's some more information. ACM offers educational and professional development resources that bolster skills and enhance career opportunities. Our members can stay competitive in the constantly changing world of computing with a range of ACM Learning Center resources at learning.acm.org. You can see some of the highlights on your screen. ACM recognizes the role of computing in driving the innovations that sustain competitiveness in a global environment. ACM provides timely computing information published by ACM, including Communications of the ACM and Q magazines, access to the ACM Digital Library, the world's most comprehensive database on computing literature, international conferences that draw leading experts on a broad spectrum of computing topics, and support for education and research, including curriculum development, teacher training, and the ACM Turing and ACM Prize in Computing Awards. ACM enables its members to solve critical problems using new technology that enriches our lives and advances our society in the digital age. Before we get started, for those of you joining us for the first time, I'd like to quickly mention a few housekeeping items shown on the slide in front of you. First, the slides will advance automatically throughout the event. On the bottom panel, you will find a number of additional widgets and resources. If you are experiencing problems with the slides or audio, press the F5 key in Windows, Command+R if you are on a Mac, or refresh your browser on a mobile device, or you can close and just relaunch the presentation. To control volume, adjust the master volume on your computer. If you have any questions during the webinar, please type them into the Q&A box at any time during the webinar and click the Submit button. I'll organize the questions as our speaker is talking, and he'll reserve time at the end of the presentation to address them. This session is being recorded and will be archived. You will receive an automatic email notification when it becomes available. And please check learning.acm.org for updates on this and other upcoming webcasts. At the end of the presentation, you'll see a survey open on your screen. Please take a minute to fill it out. Help us improve our webinars. You may also open the survey at any time throughout the presentation from the menu dock at the bottom of your screen. Finally, you can also use Facebook and Twitter widgets on the bottom panel to share the presentation link with your friends, as well as tweet comments and questions using the hashtag #ACMLearning. We'll be watching for your tweets. We also have a new community discourse page to continue the discussion after this webcast, including questions we won't be able to get through during our Q&A session. Today's presentation is Open Collaboration, the Eclipse Way by Mike Milinkovich. Mike has been involved in the software industry for over 30 years, doing everything from software engineering to project management to IP licensing. He has been the executive director of the Eclipse Foundation since 2004. In that role, he is responsible for supporting both the Eclipse open source community and its commercial ecosystem. Prior to joining Eclipse, Mike was the vice president in Oracle's development group. Other stops on the way included WebGain, the Object People, IBM, Object Technology International, and Nortel. Mike currently sits on the board of the Open Source Initiative on the executive committee of the Java Community Process and is an observer and past member of the board of OpenJDK. Mike, I'm really looking forward to your presentation today. The stage is all yours.
Thank you, Will. I really appreciate the opportunity to do this presentation. I've got a lot of respect for the ACM over the years and read many of your journals, especially back when I was a grad student. And it's a real pleasure to have this opportunity to talk about how we do things at Eclipse and just sort of educate everybody a little bit about the broader open source world as well. So thanks again, and away we go. So there's a few things I want to talk about today. So open source and open collaboration is probably, basically stake out what I mean by those phrases and what they mean to today's world. Talk a little bit about how we do things at the Eclipse Foundation, and hopefully get across the message that open source can be a very well-governed process by which open collaboration and innovation can occur. And then at the end, I want to talk a little bit, I know there's going to be quite a few researchers in this audience, and talk a little bit about how open source, and in particular the way we do things at Eclipse, has been used by researchers to commercialize their work, but also provide processes by which research groups can collaborate and help achieve their research agenda through open source and through the Eclipse Foundation. So I'm sure with this audience, it doesn't need to be said, but nonetheless, it is clear that software is an ever-increasing important part of innovation and technical process throughout basically all avenues of human endeavor. And this phrase, software is eating the world, comes from a blog post from Mark Andreessen a number of years ago, and really talked a lot about sort of how a lot of the venture capital funding was flowing into software-driven companies, and I think that's absolutely true. But one of the things he didn't really focus on quite so much in that article, and I think is increasingly true, is the way that software is very quickly becoming basically the mechanism by which the features and products that customers and consumers are looking for are being implemented. So if you look at Airbus is one example, the amount of software that is going into an aircraft. When they first started the Airbus program, which has always been a fly-by-wire program, there's 23,000 lines of code in an Airbus A300. And now they're up to, with the 380, 108 million lines of code. So several orders of magnitude increase the amount of code that's going into these basically flying devices. Increasingly in automotive as well, we see software driving innovation, and everything from engine control and performance through to the kind of consumer electronics that are really helping car companies differentiate their products. And this is actually quite an old slide. I'm quite confident that it's not uncommon today to have cars with well over 150 ECUs in them, and those numbers are only going up from release to release. So if you go back to software is eating the world, it's not just about software-driven internet companies like the Googles and the Facebooks and Twitters, but ever increasingly software is becoming a key part of the world around us. And you start to hear more and more about this as phrases like Internet of Things, where technology is being sort of subliminalized. It's being pushed so that it's not really recognizable as a computer, but it is very much a software-driven device which is changing our physical world and our social society around us. Increasingly, software matters to industry, and you start to see stories where software has made a huge difference for the commercial aspects of a company. Things like Boeing's 787 program, being delayed by a year by brake system software. Toyota, the Prius brakes. Of course, there's the famous Volkswagen diesel scandal as well. So software is getting the attention of people in industry that primarily had thought of themselves in the past as hardware manufacturers, whether they be airplanes or automobiles. Now increasingly software is becoming both the vehicle that they deliver value to their consumers, but also a big source of risk for their company as well. And I think GE's CEO, Jeff Immelt, said this perfectly a few years ago when he said in the GE's annual report that every industrial company will become a software company. And this is a transition that is happening throughout pretty much every single aspect of enterprise or industrial endeavors, where companies are realizing that software is no longer sort of tangential to their business, but is now becoming an absolutely core practice that they have to master in order to deliver value to their customers. But what GE and a lot of these other industrials have not yet figured out is that every software company has become an open source company. And I think that this transition is actually something that we're going to see more and more of, where companies realize that in order for them to master software, they're going to often have to also master open source. And not just open source in terms of being able to take free technology, but also participate in upstream communities and learn the value of contributing to open source as well. So at the Eclipse Foundation, we've used this open source maturity model for quite a few years to kind of think and talk about where companies are in terms of their maturity around adopting open source. And basically all of the software companies, and with Microsoft being a somewhat late convert, but even with Microsoft embracing open source, basically the entire software industry, as we know it, has learned to embrace open source as the way to innovate, the way to participate in community, and the way to drive software forward. And the next decade, I think, is really going to be around helping industrials and enterprises make that same transition from learning to master software and from then learning to master open source as a way to participate and innovate. So if that's sort of the agenda, what do we mean by open source and open collaboration? So probably the easiest way to understand open source is that fundamentally it's about software freedom. These four tenets were originally written by Richard Stallman, who's the founder of the free software movement. Many of you may know of him through GNU and the GPL. But effectively, software freedom and open source is all about the ability to run programs for any purpose, study the source code, be able to change it, be able to distribute the copies of the software, including any changes that you may have made. And so those basic four freedoms are the underpinning for everything that we call open source. And one of the interesting transitions is over the last, say, 20 years or so, these four freedoms have gone from a crazy idea to being understood as the way to do business in the software world. And that's an incredible transition to have happened in a relatively brief period of time. But in addition to those four freedoms, I think open source can be also best understood as a set of key principles on how to, or best practices perhaps, on how to run open source projects in open source communities. And the first of these is transparency. And what transparency is about is making sure that projects have make sure that all of their decisions, both technical and cultural, are made in the open, where others can see the decisions being made and can participate in those decision-making processes. So transparency is absolutely key. Every project plan, every change, every team decision needs to be documented in a way that the outside world, the people outside of the immediate team, can understand what's happening with the project. Openness is often confused with transparency, but it's quite a different thing. Openness is really about being open to all comers. So this is about being able to take in submissions or contributions from people regardless of where it's coming from, or who perhaps their employer is, and just judging things totally on their technical merits and pulling them in. Not judging, where the origin is or who that person might be. And meritocracy is about how do you judge how people get to join in on an open source project. And meritocracy is really, I think this sort of key, as a key principle, was probably first formulated by early open source organizations like the Apache Software Foundation and communities like Debian, where people would step up and say they wanted to contribute code. But before they were given sort of the passwords for the servers and the ability to push code into the main line, they had to demonstrate that they had the merit to do so. And then they were voted in as a member of the team by the rest of the team. And I think so that process of people learning how to contribute to a particular project and then becoming accepted as a contributor and ultimately as a committer or maintainer, I think is another key aspect of a well-run open source project or community. So if open source is the solution, what are some of the things that it addresses? So first of all, it's really about doing smarter, better business. And really demonstrated time and time again that open source allows you to save costs, get faster time to market, and better quality for the software. Enables collaboration is absolutely key. So consistent sharing of intellectual property under open source licenses means that everybody understands that they're on a level playing field and that they have the ability to use, under the software freedoms, use, modify, and distribute the software for their needs, whether they be commercial or simply as a hobbyist. And as we've seen time and time again, free is a really good price if you want people to adopt your technology. And software is somewhat unique from sort of, say, an economics point of view in that the more people use software, the more valuable it becomes. Typically, use of a particular asset will, wear it out, but that's absolutely the opposite with software. So rapid adoption of technology is key to success in our industry, and open source clearly enables that. And scale. So when rapid adoption of technology is one thing, but just in terms of being able to scale business models means that you can, with open source, you can do things that scale to the millions and billions in ways that are simply not possible if you're licensing software in the traditional commercial sense. So when you start thinking about things like IoT, for example, very clearly the scale that we're talking about with IoT in terms of the billions and billions of devices is really only possible if the underpinnings for the solutions that go into IoT are based on open source. Another thing that open source is absolutely key enabler for is developer enablement. And so, again, drawing an example from IoT, if you look at the number of developers that need to be recruited, trained, and, say, kitted out for the IoT over the next number of years, we're talking about enabling several million developers that are new to a domain. Clearly, that's only going to happen if the tools that these developers, the IDEs or editors, the frameworks, the runtimes, the protocols, if the fundamental building blocks of the solutions that they're building are not open source, we're just never going to get to the kind of numbers that we're talking about here. Developers also have really changed in terms of how things in terms of how technology is acquired. Once upon a time, software would be acquired through a traditional procurement process, oftentimes by executive fiat. But now developers are voting with their feet in terms of what technologies are winning in the marketplace. And what this chart is showing is, I think, one of the very best and most widely known examples of this, where if you go back about a decade ago, there was a lot of conversation about how the programmable web was going to be built. And was that going to be built with SOAP? And SOA was the technology of choice from all of the major enterprise companies, or was it going to be built with REST, which was a sort of a competing technology, but that happened to be open source. So you had a situation where you had REST, and it was bundled in with the Apache web server, which was and to this day is still the most widely used web server as a technology, so available for free to developers. Or SOAP, which was, and again, SOA was backed by all of the enterprise software vendors, you know, the Microsofts, IBMs, SAPs, Oracles, you know, they were all supporting SOA. But ultimately, and as we all know, the winning technology is clearly REST, and that is largely driven by developers making individual choices about which technology they want to use. And clearly, and more every day, developers are showing a strong preference for adopting open source tools and technologies. A recent example, again drawing from the IoT, there's a well-known Internet of Things protocol called MQTT that actually existed for quite a few years before it was open sourced in 2012. And as you can see from this chart, the adoption or the interest in MQTT as a technology was not particularly great for quite a few years, even though it had been around for pretty much a decade. But by open sourcing MQTT, developers all of a sudden started getting a lot more interested in it. And a lot of this has to do with their ability to simply grab it and use it in an application or a product. So this is a great example, current example of developers voting with their feet for an open source technology. Another key point on why open source is becoming more and more prevalent from a business perspective is that, frankly, the old business model of software licensing as the way that you make money on software has really disappeared. Of course, it hasn't, I'm exaggerating to make the point, it hasn't completely disappeared, but more and more rare is it that a business is making money off of strictly licensing their software. Most of the enterprise software companies, and here I'm thinking of the likes of Oracle and SAP and others, have moved to a software as a service model. So rather than licensing on-prem software, they're pushing their customers towards a cloud-based solution. And you know, there's various ways that this is happening, but fundamentally, business is being done where, and again, there's sort of this paradox here where software is becoming more and more important, but at the same time, the business model of actually charging money directly for software is becoming increasingly unlikely. So that's been a very, very large change in terms of how people are monetizing the software that they're building. Innovation is also a really key point in terms of why open source software is preferred, not just by developers, but increasingly by executives in terms of their understanding of how to more rapidly innovate. Because what open source is enabling at its fundamentally is permissionless innovation. It used to be that as a developer, if you wanted to try a new piece of software, you might have to sign a non-disclosure agreement. You might certainly have to do a trial license, perhaps arrange a proof of concept with the vendor. And so there was a lot of impediments to just simply experimenting with a piece of software. By making that process permissionless, where developers can simply download and use pieces of technology, it vastly accelerates the rate of experimentation and the way that developers can try innovating by integrating different pieces of software and pulling things together in new and interesting ways. So what you end up with open source is a far higher rate of innovation than what is even possible with commercial software. Another key point is that open source, well-run open source communities are not just limited by a particular company or a particular hierarchy. We often get asked at the Eclipse Foundation, because we have hundreds of projects, almost getting close to 2,000 committers that are working on those projects. How is it possible that such a small organization can run so many different things at one time? And the answer is that we don't try to run everything ourselves. The role of a foundation is not to control what's happening in the community, but to simply enable it. So what we have here is a situation where the capacity expands as your community expands. So that's a very completely different way of thinking about the capabilities or capacity for for an organization to produce software. So despite these, I think strong business motivations for open source, nonetheless, we still get a lot of questions about how does this stuff really work? And there seems to be a lot of people that still believe that ultimately open source is chaotic, that the way things happen is, ill-disciplined and uncontrolled. Frankly, nothing could be further from the truth. There's well-run open source communities and projects have all kinds of examples of how do you manage community contributions, well-disciplined processes for bringing change in, well-managed processes for intellectual property, and so on. But really what all of these questions are boiling down to is, are you open source guys a bunch of clowns? And I think that's really, we still have some work to do to sort of convince people of that. But if you look at organizations like the Linux Foundation, the Apache Software Foundation, the Eclipse Foundation, every one of those organizations now have a long history of well-produced, good quality software from their organizations that are being used by industry in a myriad of places. So let's turn now to talk a little bit more about how we actually do things at the Eclipse Foundation. So just a brief history of Eclipse. I'm sure not everybody is familiar with our history. So the original project, the original Eclipse IDE, was launched by IBM in 2001. And one of the things that was unique about the way it was started was that it had a founding consortium from the very beginning, led by IBM, but with participants like Borland and Red Hat and a lot of others. The Eclipse Foundation was created in 2004 as an independent not-for-profit. So that's when it became a fully independent organization. And what we've done is in 13 years is we've grown from a very sort of singularly focused organization around the Java IDE and so on to something which is much bigger and much more diverse. We have over 240 members, over 300 projects, and a number of working groups that we'll touch on in a moment. But the single most important change has been this transition from a single project to a community of projects. So there's a lot of technology at Eclipse that you probably don't know about, especially in areas like IoT, science, and geospatial areas where that you typically think of. If you know Eclipse, then you probably think of it as a Java IDE. But we have, like I said, well over 300 projects that are in a very, very wide range of technology areas. As an organization, one of the things that I think has really differentiated the Eclipse Foundation from a lot of other organizations is, starting very early in our history, we started this notion of wanting to be predictable. And so we've actually been for 11 or 12 years now doing what we call annual release trains or simultaneous releases, where we pull together a very large collection of projects and they ship all on the same day. And this is a non-trivial amount of code. So in the last couple of releases, it's been around 81, 82 projects and over 70 million lines of code, which is quite a substantial amount of software. And as you can imagine, having the maturity of process to be able to do this is actually quite a feat for an organization that's as loosely coupled as an open source community like Eclipse. So how do we do this? So basically, we think of the role of an open source foundation is breaking down into 5 major pieces. And the central piece is really around governance. So how are decisions made? Who gets to make them? How does intellectual property managed? Is it a level playing field? This is fundamentally the role of any open source foundation, and one that we take very seriously at Eclipse. Next thing that we provide is infrastructure. Now, we have our own infrastructure, so we have a Forge to host development and IP, bug databases, all of that kind of stuff, all the typical kinds of things that you would expect for providing infrastructure for doing open source development. Eclipse projects can also use GitHub, for example, though, as well, if they'd rather use an alternate infrastructure. Definitely a core value for what we do at Eclipse is around IP management and licensing, so making sure that there's a common set of legal agreements, and it's really about making sure that everybody that is contributing code and is using code understands what all the legal agreements are, but also making sure that the IP is well managed so that companies and adopters can use the technology coming from the Eclipse Foundation in commercial products, so making sure that they feel that they can safely include that in the technology that they're shipping under their name. Projects and processes, so making sure that we have development processes that scale, development processes that support the involvement of many different organizations and also individuals. We're actually well over 40% of all the contributions to Eclipse projects are coming from individuals, so it's not strictly about companies or research institutes and the like contributing code. It's very much a distributed thing as well. And then finally, ecosystem development. So supporting the technology that's happening with things like marketing, conferences, events, making sure that all the stakeholders can participate, and providing sort of a holistic approach for how technology gets adopted by individuals and companies. A couple of years back, we started noticing that because we were getting so many projects and so many companies involved, that it was getting difficult to basically for companies and individuals who had like interests to find each other. So we came up with this model of basically little miniature industry consortiums that we call Eclipse Working Groups that allow individuals and companies to pull together a collection of projects or technology that focuses on a particular domain area. So some examples that we have at Eclipse is one that's actually doing extremely well these days is IoT. So if you're interested in Internet of Things technology, if you go to iot.eclipse.org, you'll find a lot of very cool technology around providing basic building blocks for IoT. There's a set of the companies that are involved. I would say that the companies that are sort of really leading the charge here are companies like Bosch and Eurotech and Red Hat that are making the largest investments in Eclipse IoT. And we're starting to really focus on creating software stacks for IoT. So there's a white paper you can find on our website that talks about the 3 IoT software stacks and the pieces of Eclipse IoT technology that are building out all 3 of these stacks. Another Eclipse working group is PolarSys, which is focused on providing model-driven embedded systems development tools. So there's a significant number of members and certainly some companies that you'll recognize there like Airbus and Saab, Thales, Ericsson, and focused on being able to have tools for sort of safety for embedded systems with safety requirements and more formal methods for how they build software. Location Tech is focused on building geospatial technology. So again, very much an area that you may have never thought of Eclipse being involved in, but our Location Tech community has about 20 different projects that are very much involved in providing geospatial capabilities, especially sort of big data capabilities for geospatial applications. We have a science working group that is building software that's used in scientific research. And by scientific research here, I don't mean computer science. I'm talking about chemistry, biology, and physics and the like, and really providing fundamental tools and tool chains for doing scientific experimentation. So next, we're just going to talk about a couple of examples of Eclipse Foundation working with the community and enabling research. So when we talk about research, what are some of the issues that we see that we think open source can help with? So one is, basically, research that ultimately dies on the vine because of lack of dissemination or commercialization. So we can definitely help with that. Reinvention versus experimentation. I mean, I can remember back when I was a graduate student building software for my thesis. I had a lot more fun writing things from scratch as opposed to learning existing frameworks. So I can say this, from my own individual experience. Oftentimes, it seems to be easier to do reinvention as opposed to focusing on what open source now enables, where you can experiment through the combination of different software packages and see what you can come up with as a solution. Closed collaboration models. We see this all the time where there's perhaps a government-funded research program, but the collaboration model is private to the organizations that are involved in the research, which means that it makes it much more difficult for anybody else to commercialize it. Also, ultimately means that the software, the technology being built is much less likely to be widely disseminated. So open source can help these with direct commercialization, and you can either do this sort of towards the end and think about open source as a path to commercialization, but increasingly we think it's better to do this throughout the research lifecycle and make sure that from the very beginning of the project that open source is one of the aspects that's being focused on. So just a couple of examples of research that's come out from Eclipse that's been commercialized successfully. So there's a company based in Vancouver, British Columbia called Tasktop that is really based on the research work by a gentleman by the name of Mick Kirsten, who built an Eclipse project called Mylar, started basically building it out. I'm not sure we'll get much into the technology, but one of the interesting things that he did was he defended his PhD on a Friday and incorporated his startup company on Monday. And as part of that path to commercialization and creating his venture company, he created this as an Eclipse project, now known as Eclipse Mylan, which is used for providing a task-based interface for the Eclipse IDE. And it's really allowed this company to grow from, 1 or 2 people up to well over 100 people now. And I think they're, in fact, even had their Series B funding. So the company has done extremely well in terms of using Eclipse and open source as the path for commercializing what was originally started off as a research topic. Another very successful story is a company called Code Trails based in Darmstadt, Germany. A gentleman by the name of Marcel Bruch started off as a PhD researcher at the Technical University of Darmstadt, really trying to solve the problem of how to make developers more productive by doing a better job of mining the information that's actually out there. So the technology in a nutshell is there's a lot of software that's out there, things like Bitbucket, GitHub, Maven Central, the Eclipse Marketplace. So why don't we analyze the source code that we actually have available to us and create a knowledge base of that source code, extract the patterns and be able to create recommendation models for what we know about the code that's out there, and then deliver that to developers. So if you go back to how they did that, they created an Eclipse Code Recommenders project, and it's really about fixing the problem of, I'm sorry, some of the formatting on this slide got a little funky, but if you hit Control Space in Eclipse or you're asking for advice on what method would you call next, the default answer in the Eclipse IDE is it's going to give you an alphabetically sorted list of 389 possibilities. As a developer, what you really want to see is a probabilistically sorted list of what's the most likely thing that you're going to want to do here. And this is what Code Recommenders has been providing as part of the Eclipse IDE for quite a few years now. The interesting thing about when they decided to bring their technology to Eclipse, the Eclipse Foundation, and start an Eclipse project, they thought that really why they wanted to do this was what's on this slide, which is really gauge if there's enough interest for a commercial product, get to see real scale, and what they found that the benefits for actually being part of the Eclipse is it gave them a platform to be go out to be able to talk to Java 1, Java users groups, etc. about what they were doing and really get the message out. They got a community award, which helped them to attract investors. And being part of the Eclipse Java IDE got them literally millions of real users, which was a huge difference, both in being able to validate their technology and their research, but also being able to attract funding to their startup. Then a second thing that they built was the Eclipse Automated Error Reporting, which also really helped raise awareness for their company and their commercial products. So in terms of a timeline, they started off in 2006 in terms of research. They became an Eclipse project in 2011, and then they've had a continuous stream of both commercial success, but also the ability to get venture capital funding, but also research funding as well. So we've actually started to think more deeply about this at the Eclipse Foundation and think about Eclipse as a research catalyst. So we actually have a program now that you can find at research.eclipse.org that's basically how can you use the Eclipse Foundation and what we're doing here from the perspective of a researcher. And really, what we're seeing more and more is that particularly in Europe, what the funding agencies are looking for are consortia that pulls together researchers with large companies and small and medium enterprises into a single research program. And open source turns out to be a really great platform for helping to enable that. So I'm just going to go through a number of examples of programs that we are working with at the Eclipse Foundation. Most of these are based in Europe. So Altea for Public is an engineering platform for doing embedded and systems development on multi-core systems with particular focus on the automotive sector. The Agile project, also funded by the European Commission, is about IoT and making sure that there's a modular platform for both hardware and software for doing IoT. AMAS is certification and assurance of cyber-physical systems, which is what you get in a lot of IoT applications. BASIS is funded by the German government and is around what they call in Germany the Industry 4.0, which is sort of like the next generation of manufacturing and process automation. For doing research into how to manage future production plants. CrossMiner is another project which is based on extracting the knowledge from open source projects and injecting it into the IDE. So this is sort of like similar to Code Recommenders in some ways, but providing deeper knowledge. Robmosis is about creating a platform and ecosystem for doing robotics software. And then another recent one is the GEMOC Research Consortium, which is a research consortium, worldwide research consortium around doing modeling languages. So how do you create and refine modeling languages? And a lot of the technology that's widely used in this modeling world is based on Eclipse projects like EMF, Xtext, Extend, Excelio, and the like. And the GEMOC is not, unlike some of the other ones I was talking about, is not necessarily focused in Europe. It's very much a worldwide consortium. One last example I just want to touch on is something which is new in our science working group, which is a project called SACC, which is focused on quantum computing. So the idea is to treat quantum computing units as accelerators in a larger HPC environment, and provide a specification and an implementation, of course, for how to treat these accelerators commonly. So very much based on what you saw with OpenCL for building using graphical computers, your GPUs. So LLVM-like language and so on for building quantum code, which then can be executed on a number of different quantum computers. So just in closing, before we get to the Q&A, just want to reiterate that the future of technology is software, and increasingly innovation in the software industry is happening through open source. So as you think about your software commercialization, your software research, and your path to innovation, I strongly suggest that you think about open source, how open source can fit into your development strategy, your community outreach strategy, your developer enablement strategy, and all of these things are fundamentally, in today's world, are being built on top of open source. And again, to reiterate, the community is the capacity, and very much what we see is that the open source community is growing larger and larger all the time, and we're continuing to demonstrate that we can master technologies and do innovation in ways in open source that can no longer be even matched by the largest of companies operating as a hierarchy. So please get involved in open source in general and the free software in general, but also I'd love to have your energy and intelligence and participation at the Eclipse community. So please get involved in one way or another as soon as you can, and jump in with both feet. We'd love to have you. So with that, I'll say thank you and turn it back to Will for Q&A.
Thank you, Mike. It's been a pleasure listening to you expand on the merits of open source, and I must say I will thank all the attendees who have been bombarding me with questions. Now, I'll summarize the first question. It all has to do with the monetary, the payback. I mean, how do you make a living from writing open source code, and how does the foundation actually make money from supporting open source software? So would you spend a moment just talking about the motivation to monetize an open source project?
Yeah, sure. So fundamentally, how do you make money on software? I think is demonstrated time and time again is that you charge for something else. So let's give you a couple of examples. Google is fundamentally a software-driven company, and is only able to achieve the scale that it does because the infrastructure that it uses is based on open source. But their monetization strategy ended up being advertising. They're the biggest, advertising channel in the world. And another example that's perhaps a little bit closer to the world that I live in is the Internet of Things. You're not going to charge for the software that is on a sensor. You're going to charge for the sensor or the gateway box, or you're going to charge for the device, even though an enormous amount of the value that is being delivered to the customers from that device is actually being done by software. So there's any number of well-known monetization strategies for software that doesn't include directly licensing the software. And the second part of that question is how are foundations funded? So it depends. So foundations like the Apache Software Foundation are set up as a 501c3, which is a U.S. tax code lingo for a charity. So they're funded by donations. Other foundations like the Eclipse Foundation, the Linux Foundation, and numerous others, OpenStack, for example, are membership funded. So we have 240 corporate and organizational members that provide us annual dues ranging from $1,500 a year up to $250,000 a year.
Very good. Okay, we have some Microsoft Shop participants today, and they are asking, are there opportunities for them in a Microsoft shop? And in particular, there's this thing that's not really open source license that Microsoft has called Open Specification Promise. Do you have any words of encouragement?
Well, Microsoft is on a journey. So I actually know a number of the people in the open source group at Microsoft quite well. And what we're seeing from Microsoft is increasing adoption of open source. They are starting to contribute to open source more and more. So for example, their Visual Studio Code, their editor that they launched a year or two is based on an open source project called Monaco, which is entirely driven by Microsoft. So we are seeing more and more Microsoft engagement with the open source community. And by the way, I should mention, of course, .NET itself. Great swaths of .NET have been open sourced. So Microsoft is embracing their own open source strategy. They're embracing open source as a way to get things done and a way to license things. But they're also becoming more and more prevalent in terms of active in the community and offering their own open source projects. I don't think that they're going to change their proprietary software model overnight, but the fact that they're, with Azure, becoming more and more cloud-focused, I think is giving them an opportunity to rethink their business model and their business models in new and interesting ways that will eventually get them to be, I think, quite a prominent participant in the open source community.
Good. Okay, we have quite a few questions about first, students who want to know more about getting information and not being discouraged that they're learning grassroots programming when really open source programming seems to be the wave of the future. So do you have any words of encouragement or suggested resources that they could draw upon to properly leverage or being positioned to leverage open source resources? Well,
when it comes to learning how to do open source, I mean, it's not about, what open source delivers is technology, but learning open source is not about necessarily learning any one particular technology stack. Learning how to do open source is really a social and cultural learning process, and the only way to do that is to jump in and participate. So whether you participate via GitHub, which is obviously a very, very widely used platform for doing open source software development, or you decide to participate in a community like Eclipse or Apache, these are all opportunities that are available to you. And I think the way to get started is you just have to jump in with the recognition that maybe your first attempt or two is not going to be successful, but you have to stick with it and be a little bit on the persistent side and find a technology that you're interested in, that you have skills that can actually contribute, and then find ways to get your ideas, contributions, and participation recognized by the project or the community. And there's no way you can do this without actually jumping in and doing it. There's some books that you can read out there that can sort of explain how these things work. John O'Bacon's Art of the Community, Carl Fogel's book on, I forget the exact title, but Carl, K-A-R-L, Fogel, F-O-G-E-L. If you look it up, it's like how open source projects work. Both are excellent resources in sort of understanding the dynamics behind the projects that you're looking at from the outside, and can give you hints on how to engage with them.
Great, thank you. A few subject matter questions as far as focus of there being projects dealing in particular with security or machine learning. How does the Eclipse Foundation, what's their point of view on security and openness?
Well, so I hear variations of this themes of this question. I think what the person is really asking is how, if all the source code is open, how can open source be secure? And that is one of the biggest red herrings out there in the software industry, that this idea of security through obfuscation has been disproved time and time and time again. I mean, just, you know, Mac OS is built on top of the BSD Unix kernel. Linux, of course, is built as an open source project, and they are demonstrably more secure than Windows. Not saying that like Microsoft has made huge strides over the last 10 years in terms of being better, but this idea that you have to hide the source code in order to be secure, I think, has been disproved time and time again. So I apologize if that was not the question you were answering. I'm sort of guessing what was the underlying question there.
I believe they were looking if there was any overall guidance that or threshold for security that was imposed on any of the software that you know, is within the Eclipse, well, is available through Eclipse.
Okay. So let me, okay, then that's a different question than what I answered. So let me try again. So we do have like various projects at Eclipse have various degrees of security concerns, right? So we deliver an IDE to millions of desktops. So obviously we don't want the IDE to be used as a vector for malware. We have a number of IoT protocols and IoT gateways, which could potentially have security implications as well. So we do actually have a well-documented security process at Eclipse in terms of how to deal with vulnerabilities. We are a CVE numbering authority, so we can, if we are aware of a vulnerability, follow the industry-recognized best practices around publishing it and publishing solutions and notifying the world that vulnerabilities exist. But we do not, at the Eclipse Foundation, have a mandated approach to security that every Eclipse project has to follow. And that's partially predicated by the fact that we have so many projects in such a wide range of areas that we've never seen a need to have a sort of a one-size-fits-all policy that all Eclipse projects have to follow.
I just have to smile. A question just came in and said, is open source code as well written as commercial code? And I'm just sorry, I couldn't keep myself from coming to the same conclusion. I think it's better written, but would you care to comment?
Yes. I'm not aware of any sort of research that's shown this empirically, but anecdotally, I've heard from a lot of different people over the years that open source code is better written than the proprietary code, largely because as a professional, if you are writing open source code, you recognize the fact that your peers are going to be reading your code. And I think that's a very powerful personal motivator to make sure that your code looks good as well as runs good, right? So I do think that there are very positive implications on sort of robust code quality in general that stem from publishing your source code.
Okay, we have time for one last question. This appears to be more political than technical, but nonetheless, it's a valid observation that most projects that you've referenced are based in the EU. How competitive is the U.S. in development of open source infrastructure for science and innovation, and do you have any policy recommendations?
So first thing to remember is I'm actually Canadian, not American. So my ability to comment on exactly how things work in the U.S. is probably somewhat limited. We do actually work with a number of the research labs in the U.S. Department of Energy, thinking Oak Ridge and Pacific Northwest and places like that. So we do have a relationship with some branches of how research is funded in the U.S. What else? My observation is that the Europeans are a little bit ahead of the U.S. in terms of on a policy level, insisting that their research consortia embrace open source from the outset of a project. So increasingly in the recent like H2020 program from the European Commission, there is a requirement stipulated in there that you have an open source approach or at least a written policy on how you're going to achieve widespread dissemination of your research results. And they did that because for a number of years, they said, we want results in open source. And what they got was on the last week of the 3-year research funding, the developers would just throw some stuff up on GitHub and say they were done. And of course, that is not going to achieve anything. You need to have people involved in the development of the code and find ways to build community around that code throughout the life cycle. You just don't throw it over the fence when you're done. So based on my observations, various U.S. departments, DoD and DOE in particular, are getting there. But it still seems like there's a little bit further to go in terms of sort of a tangible policy position on how to do this.
Well, that was a great answer, and it answered about 5 other questions that were lurking in the wings. But I'm afraid we've run out of time. And once again, I'd like to thank Mike for this informative presentation and insightful answers to the many questions. A special thanks to each of you for taking the time to attend and participate today. This webinar was recorded and will be available online in a few days at learning.acm.org webinar. You can find announcements on upcoming webinars and other ACM activities at learning.acm.org and acm.org. Also, please fill out our quick survey, where you can suggest future topics or speakers, which you should be seeing on the screen now. On behalf of ACM, Mike Milinkovich, and myself, Will Trace, thanks again for joining us, and I hope you will join us again in the future. This concludes our webinar.